All right, welcome back to the next video in the series. So this contraption looks a little bit different. I'm going to swing the camera around here just a little bit, just so you can see. We basically have a triple beam balance being held up by this rod right here. There's a place in the bottom of the triple beam balance for this type of experiment. And so you just basically, once you have the rod onto the proper stand, you put the triple beam balance on the rod. Now, it throws things off just a little bit different than when I had it on the desk. And so what I'm going to be looking at is the mass of this object, the measured mass of the object in air, because right now it's just suspended by a string, and I do have a little bit of string here, which might account for the difference. And then I want to figure out what it is in terms of when I put it in water. What is the measured mass? It's not the actual mass, because the mass shouldn't change by dipping it in water. But I'm looking at that difference there. Because, and frankly, right now I've got two forces acting on it. I've got the tension on the string acting up, and it should be, as long as it's not accelerating, should be equal to the weight of this thing going down. So as long as it's in equilibrium, I can measure mass. I can basically come up with an apparent mass here, with an actual mass. And so there it is. It's sort of suspended right there. My hand behind it just to give a better view. There's nothing. It's not actually touching the book down here, and I'll talk about the books in just a second. So when I look at this, and it's 81.45 grams, and that might be taking into account the mass of the string. Now I want to dip it in the water. I want to put this in the water, and I want to see what the mass looks like next. Because when it's in the water, basically I've got a buoyant force acting up, as well as the tension in the string, and I've got the force of gravity acting on this object acting down. The buoyant force should be propping it up, and that should basically make the mass seem less. So let's put it into water. Now, a couple things here. Ideally, the object is not touching the sides, because that adds in an extra force. Also, the water should still be above the level of the rod in here, which it is. The water needs to be below, well, basically, the displacement should be what it was before, and it is. It's at 98 milliliters, or 98 cubic centimeters, if you recall. I don't want this thing touching the bottom either. In other words, I don't want the metal thing I have inside touching the bottom. So I don't only want it touching the water inside, and then of course I need the string in order to suspend it. So now I want to see what the mass is at this point. And so basically coming up here, the same type thing before. It is now less than that. Now I know roughly what the answer is going to be. And so let me drop it down. Now I know what it's roughly going to be. Well, we'll talk about the y in just a second. All right, and now I'm coming up with 71.2. 71.2 grams of what's being measured. We'll come back in the next video and actually do the analysis, but this is one of the setups that you're going to be doing. I have books right here propped up because I don't want to be holding the cylinder here because my hand's going to shake some, and that means the water is going to be pushing up and down, and we've got an acceleration, and it throws things off. So I want it as stable as possible. There's a whole slew of books in the room for propping things up and putting this underneath it. Next video, we'll do analysis, and then I think that'll be the last one.